today's lesson, we are going to look at parallel and perpendicular lines. So parallel lines are lines that will never touch or intersect. So you could think of like kind of like railroad tracks, is like that. They'll always be side by side, but they're never going to cross. Right? And with parallel lines, making the connection to the equation of a line, or some of the new terminology we've looked at, because you may already know what a parallel line is, but adding in some new terminology, parallel lines are lines where the slopes are the same. So we can see some examples here. They all have a slope of -1/2. And even though we don't see slopes with these two lines in red and in blue and red, they would have the same value. So again, just look at some comics looking at parallel lines, come from a parallel universe. What are parallel lines? They're vegetarians, huh? They never eat meat. Or it's not never eat meat. They never meet. I kind of messed that one up. But you get the idea. Parallel lines, two lines that never meet, like me and my healthy sleeping habits. And then moving into perpendicular lines, which would be the opposite of parallel, right? So perpendicular lines, not opposite of parallel, but in our terms, kind of like the opposite kind of, not opposite term, but kind of like a complement to it. So perpendicular lines, lines that meet at 90 degrees or a right angle. So all of these lines, they cross or they meet and they form a 90-degree angle. Now, again, making the connection to what we know about equations of a line, in this case, slopes are negative reciprocals. And what do we mean by that? Well, what we mean is that the slopes are flipped and the opposite sign. So if I look, for example, at the one line, it has a slope of 2. The perpendicular line has a slope of -1/2. So our thing has been flipped and the sign has been changed. Right, so that's what we mean when we're referring to negative reciprocals. So again, some cartoons on that. Don't be frightened. I'm you, but I come from a perpendicular universe. We've opened a portal to a perpendicular dimension because obviously they're 90 degrees from each other. Perpendicular. And then again, you may have seen this before, kind of comes up sometimes when looking at parallel and perpendicular lines. So parallel lines have a lot in common, but they never meet, ever. You might think that's sad, but every other parallel line meets once and then drifts apart forever, which is pretty sad too. So kind of just a different way to look at the lines, but not to kind of get on a down note. Let's kind of do something a little bit more uplifting, such as examples. So let's work through a couple of examples. So in example 1, we want to determine the slope of a line that is parallel to the given line. So all we're concerned about is the slope, or that m value. So if it's parallel, it has the same slope. So I just have to identify the slope in my equation. In this case, it's -5. So the slope of a line parallel to that will be -5. If I look at B, again, identifying the slope, 1/3. Because it's parallel, that means the slope of my new line has to be 1/3. The y-intercept can be whatever it wants, except for obviously the same value, because if the y-intercept of my new line was -2 and it had the same slope, well, I've just recreated the exact same line. So the y-intercept does need to be different, but the slope is going to stay the same. For example 2, we want to determine the slope of a line perpendicular to the line that we're given. So in this case, again, identify the slope or the multiplier. So in this case, it's 4. If I want a perpendicular line to that, I need to flip it. And by flip it, again, 4 as a fraction is 4/1. So when I flip it, it becomes 1/4. And then I give it the opposite sign. this fraction or this number, the original slope is positive, so my perpendicular slope will have to be negative. So that means the slope for my given perpendicular line will be negative 1 over 4. For B, same idea. Identify the slope. Because it's perpendicular, it's going to be the negative reciprocal. So negative 1 over 2 becomes, we flip it, 2 over 1, or just 2. And then the opposite sign. So it goes from a negative to a positive. So in this case, the slope of a perpendicular line to the line given would have a slope of 2. Now in this case, the y-intercept can be any value. It can even be the same value of the original line, because the key difference here is that the slope is different. Right? The slope is that negative reciprocal, so we are allowed to use the same y-intercept if we were asked to come up with an actual line. So example 3, similar idea. We're given two pairs of slopes, and we're going to identify whether it's parallel, perpendicular, or neither. So looking at A, slope 1 is 1 over 2, slope 2 is just 2. Now you might at first glance say, well, they're perpendicular. One thing to keep in mind, they're both the same sign. 1/2 and 2, they're the same sign, right? So even though one's flipped, they don't have opposite signs. They're also not parallel. So the first one is neither. For the second pair, 3 and negative 1 over 3, in this case, they are flipped. So one is flipped, or they're flipped from each other, and one is positive and one is negative. So this means that they are perpendicular in this case. So hopefully you can see the difference between A and B, and why one is perpendicular and one is considered neither. The C value, or not the C value, for C, we have the first slope 2 over 3, and the second one is 4 over 6. Again, at first glance, you might say, oh, they're different, they're not flipped, they're neither. However, if I look at the slope of 4 over 6, I can actually reduce that to 2 over 3. So in this case, they're actually parallel. And you might say, well, why would I get a slope that's 4 over 6 and not 2 over 3? Well, depending on the points that you have. Right? When we looked at graphing equations, we looked that we can go from any pair of points or any 2 points. So we may skip over one of the first ones just to save room, to make it a little bit larger, or easier to do the rise over run. Whatever the case may be, we can have different slopes that are just equivalent fractions that mean the same thing. Example 4, we want to write an equation of a line that is perpendicular to the line 8x minus 4y plus 12 equals 0. Now you might question that isn't an equation of a line, or not one that we know of. And that equation is actually what we call standard form. So it is the equation of a line, it's just written differently. Right? So what we need to do first is we need to take our equation and rewrite it in y equals mx plus b form. So essentially what we need to do, we need to have the equation, or we need to have y on one side and the x or the mx and the b on the other side, or basically the two other terms on the other side. So we can move things or rearrange things similar to when we were solving equations. So if I move the 8x to the other side, or if I want to cancel out 8x on one side, I'm going to do the opposite, or subtract. I'm going to subtract 8x from the other side. And again, by other side, I mean other side of the equal sign. I'm going to do the same thing with 12. I'm going to subtract 12 from one side, subtract 12 from the other side of the equal sign. I'm left with negative 4y equals negative 8x minus 12. Now, I didn't subtract the 12 from the 8x because they're not like terms. So again, going back to the previous units, right? We have to rearrange equations from our solving equations unit, looking at collecting like terms, or in this case, not collecting like terms, back from that our algebra unit. Now you might say, well, this is in y equals mx plus b form. I have y on one side, the m and the b on the other side. However, I need to get y by itself. So I need to get rid of this -4. Again, going back to previous units, we said that when we have a coefficient and a variable side by side, the operation connecting them is multiplying. So the opposite of multiplying is dividing. So I'm going to divide by -4 on one side, and I'm going to divide the entire other side by -4 as well. One side gives me just y because they cancel out. And on the other side, -8x divided by -4 is 2x. And remember, everything is divided by -4. So -12 divided by -4 is +3. So this is the equation of a line that we are given. So we haven't answered the question yet because we want to come up with a line that is perpendicular to this. So I need to find out what my m value is because that will determine whether it's perpendicular or not. I can see from my first one, or from my original line, that my slope is 2. I needed to make it the negative reciprocal. So this needs to become flipped. So 1/2 and the opposite sign, so negative. So now that I know what my slope needs to be, I can write an equation, y equals -1/2x. And then for the constant, it can be whatever we want it to be. It could be 0, so we don't even need to write one. It could be +3, like the other one, or the other line. It could be any value that you want. Whether it's positive or negative, it doesn't matter. The main thing is that the slope is the negative reciprocal. Lastly, example 5. So a triangle has vertices A, which is the point -2, 5, B, which is the point 6, 8, and C, which is the point 1, -3. So we want to determine, is this triangle a right angle triangle? Now, you may have no idea where to begin, but because we're given some points and we're given a graph, let's at least plot those points and see what we get. So -2 and 5 is point A, B is 6 and 8, and C is 1 and -3. Well, I have my 3 points. I can clearly see my triangle. So let's join the lines to at least make our triangle. Maybe that way it will tell us if it's a right angle or not. So I see my triangle. It looks like I have a right angle here. It looks like that's a right angle, but I'm not 100% sure, right? Because maybe my scale's a bit off. Maybe my lines are a little bit crooked. Right? I could guess or make a good guess that it does look very close, or it looks like it could be, but I could be wrong. So how do we check? Well, the fact that I drew in a right angle there should be a hint. What I mean by that is, because I have a right angle between these two lines, the line AC and the line AB, because they make a 90-degree angle, that means they should be perpendicular. So again, when we have a right angle, that means two lines are perpendicular. So now I just need to check if these two lines are perpendicular. And I can do that because I've learned how to find the equation of a line from 2 points. Now, I don't need the full equation, I only need the slope. So I'm going to look at the first line, AB. Again, I'm just going to keep it color coordinated, so actually don't want to confuse it with the other blue line. So I'm going to look at AB. So the X and Y values, those just come right from the points that I have. So -2, 5 for the A point, 6 and 8 for the B point. Let's look for the change in y, change in x. So from 5 to 8, this increases by 3. From -2 to 6, that's an increase of 8. So my slope, or m value, which is change in y over change in x, is equal to 3 over 8. So I have one line done. Let's do the other line. Right, so we'll do the red line, AC, x and y. A again is -2, 5, and C is 1, -3. So let's see what we get. Change in y. From 5 to -3, that's -8. And the change in x from -2 to 1 is 3. So for my slope, change in y, change in x, -8 over 3. Now I have the slope of my two lines. I just have to compare the two and see if they're perpendicular, which in this case they are. So they're negative reciprocals of each other. They're flipped and one has the opposite sign, or then they're opposite signs. So this is perpendicular. And because it's a perpendicular or right angle, it means this triangle is a right angle triangle. So that was just a little bit of analytic geometry, just using what we know about equations of a line to kind of prove some geometric properties. But the main thing from this is understanding the difference between a parallel line and a perpendicular line. And not just understanding the difference, but also being able to recognize if given an equation of a line or a pair of equations or a pair of slopes, are they perpendicular or are they parallel?